Live. Hello, everyone. Welcome to Red Planet Live. I am your host, Ashton Zeth. I'm elated to be hosting the Mars Society's podcast and leading the conversation about human exploration of the universe and the future settlement of Mars. As a longtime space enthusiast, I am passionate about STEM education and making humanity an interplanetary species. Thank you, everyone, for joining us today and supporting Red Planet Live. Today's episode is all about the University Rover Challenge. For those that are unfamiliar with URC, it's the world's premier robotics competition for college students. Held annually in the desert of southern Utah, URC challenges students to design and build the next generation of Mars rovers that will one day work alongside astronauts exploring the Red Planet. My guests today are intimately familiar with URC. With me today is Kevin Sloan, URC Director, and two student participants, Riley McAllister and Tal Donde. Thank you, everyone, for talking with me today.
No worries.
Thanks so much for having us on.
Absolutely excited.
Yeah, thank you.
Guys. Well, with that, let's do some quick introductions. I'm going to start with Kevin. Kevin Sloan holds bachelor's degrees in electrical engineering and mechanical engineering from the Pennsylvania State University and a master's degree in systems engineering from the University of Maryland. He currently works in science and technology program management in the DC area. He previously served as the commander of Crew 50 at the Mars Desert Research Station and has been the director of URC. Thank you, Kevin, for being here today. And next we have Riley McAllister. Riley represents Team Mountaineers from West Virginia University and the reigning URC champions. He was last year's science sub-team lead and will be the CTO this coming year. Riley is starting his senior year and majoring in computer science and engineering. After graduation, Riley intends to pursue a career in robotics and embedded systems. Hi, Riley. And lastly, we have Tal.
Hey, how's it going?
Oh, there we go. We had just a little delay there. And last, we have Tal. Tal represents Team Nova Rover from Monash University in Melbourne, Australia. Tal is a third-year undergraduate student pursuing a bachelor's degree in robotics engineering. He has been involved with Nova Rover for the past 2 years as a chassis engineer and served as the team's COO last design cycle. Tal is also looking forward to a future career in robotics. Again, appreciate everybody for joining me today.
Happy to be here.
Well, before we jump into questions for the guys here, I have two Mars Society announcements to share. The first is the Mars Society is proud to report the successful end of our latest expedition to our research station on Devon Island, located in the Canadian Arctic, about 900 miles from the North Pole. This multi-week mission was the first crew visiting the station since 2017, and the dedicated international crew of 5 from Australia, Canada, and the US updated the main habitat for the Flashline Mars Arctic Research Station, setting the stage for future annual expeditions. The Mars Society's Analog Station program strengthens our journey in the understanding of Mars-like conditions in remote places on Earth. For more details about the FMARS program, please visit fmars.marssociety.org. And the second announcement, in another remote Mars analog location, the Mars Society has been working closely with Mongolia's Mars V project, which aims to establish a Mars simulation station in the remote Gobi Desert. The project, operated by Mars A, the Mongolian Aerospace Research and Science Association, is aligned with Mongolia's broader space ambitions and has gained substantial support both locally and internationally. Just in the past month, the Mongolian Prime Minister visited the U.S. for high-level space discussions with Vice President Kamala Harris and NASA Deputy Administrator Pam Melroy. Mars V and their partnership with the Mars Society were part of those discussions, and NASA has pledged to send a prominent speaker to the Mars Society's annual convention in Tempe, Arizona from October 5th to 8th of this year. Stay tuned for more updates on Mars V. Okay, and now we're going to shift gears and we're going to get into the fun stuff. On Red Planet Live, I do a segment called Question of the Day. Today's question is inspired by some behind-the-scenes Red Planet Live actions. If you follow me on social media, you may have seen this already, but today we officially launched Red Planet Live on Spotify, Apple Podcasts, Amazon Music, So today's question is, are you a Spotify or an Apple person? Now, before you answer, think about it for a sec. Most people are one or the other. They feel very strongly about their affiliation. I am the same way. So question to you guys, are you a Spotify or an Apple person? Riley, let's start with you first.
Yeah, unfortunately, I don't think I have a very interesting answer. I haven't really used the Apple Music app, so really it's kind of Spotify by default. It's just what I'm used to and the interface that I like, so Spotify probably.
All right. One for Spotify. Kevin, what about you?
You know what? I'm actually going to buck the trend here. I'm going to go with neither. I actually use Amazon for finding podcasts.
Okay, all right. I like it. There we go. And what about you, Tal?
Diehard Spotify fan.
I'm right there with you. Spotify 100%. I think I've converted a few family and friends from either not using anything or just by default because they have an iPhone using Apple Music. Spotify is for sure the way to go. All right. Well, I think Spotify won this competition here. So thank you for your feedback there. But before we jump into questions, which is the fun part of the episode, I want to remind our audience that if you have any questions for any of my guests here, Kevin, Tal, or Riley, please post them in the chat. I'll be sure to read your questions throughout. So let's start. Let's kick things off. I'm going to focus on Kevin. I'm going to for a couple minutes here and ask some questions about URC. Can you give us some insights into the URC challenge as a whole? What is the process for applying? How do you select teams? How did it start? Let's start there.
Yeah, a great place to start. Yeah, we'll start at the top there. So for those that aren't familiar with the University Rover Challenge, we host the final competition at MDRS, the Mars Desert Research Station, which is the Mars Society's analog station. It's out in southern Utah and the desert out there. So we put everything in the context of those human crew rotations out there. So when we're talking about rovers for URC, we're not talking about rovers the same way we are with Curiosity, where you're dealing with 20-minute time delays and you're dealing with very limited motion that occurs over the course of a day. It's all based on the idea that you have a rover that is supporting some of the early human crews to Mars. So you have a limited number of astronauts, very limited resources, and a high number of demands on their time, both on facility maintenance, all the science objectives they have to accomplish, just a long litany of things. You can ask anybody who's been to MDRS or Mars just how busy their day gets. So the goal is, how can you have rover assistants that can amplify and extend what they do in the field? So with that in mind, we put out a series of competition rules every year. Usually at the beginning of September is when we release the next competition year's rules. It's aligned with the academic calendar year. So from that, teams get started working in the October timeframe. We open up registration to any college teams. They're welcome to apply. And then at that point, it's full speed ahead. There are 2 design milestones that teams have to pass through. The first is at the beginning of December each year. They have to submit a preliminary design review report. This is usually a pretty easy milestone to pass. We're really just looking to see that teams have the right resources in place, both in terms of facilities, financial support from sponsors or the university, that they built up a team with a structure, that they actually have a project management plan. They understand the magnitude of taking on an effort this complex. They know how to organize their work, and we think they're going to be successful. It's an opportunity for us to give teams feedback, help set them in the right direction. And if there are teams that we think maybe need an extra year of preparation, we give them that feedback as well. Fast forward to the end of February or beginning of March timeframe, teams then submit a second package, which is the System Acceptance Review Package, or SAR. This is, without a doubt, the bigger and more competitive of the milestones, because it is actually a competitive milestone. Regardless of the number of teams that register and apply to compete in URC, we always down select to a fixed number of teams. It's typically 36 teams as our cutoff. This year we made a special exception and accepted 37 teams. But if we have 100 really strong teams that all submit reports and videos showing the rover doing amazing work, we go through and we score them. And based on the rack and stack of how those scores play out, we draw a hard line in the sand, and the number of teams that qualify is set. Those teams get invited to come out either at the end of May or beginning of June, depending on where the calendar is falling each year, for the URC finals. And over the course of about 3.5 days, teams in the rovers have to compete in 4 separate missions out at MDRS.
Okay. And so with the teams that are applying, are they just U.S. teams? They're international teams? Where do you see most applicants coming from?
They are international, and it's something at the start of URC we didn't even consider international growth of the competition. But over the years, it's expanded quite a bit. This past year, we had teams from 15 countries that had applied. And there are many more countries represented that are competing in similar rover competitions that have stood up, kind of spin-offs of URC over the years.
Mm-hmm. Okay.
But U.S. teams definitely are the biggest presence for URC just because of proximity.
Sure. Yeah, that makes sense. Especially if you're hosting it, at MDRS, obviously schools and teams that are closest to that would make sense that you'd see more of those applicants, obviously, since they're close by proximity. So you've got teams apply, they get to a certain level, and they're getting towards that final rounds. You're getting to the championship here. What does that scoring criteria look like? What are the benchmarks? What do they need to achieve to get to that next level?
Yeah, so the scoring for the actual final rankings actually starts with that system acceptance review that I mentioned. The same scoring process that we use to down select those final teams, those scores carry over, and that's your first 100 possible points in the URC finals. There are a total of 500 points possible, so the other 400 points come from the 4 missions that teams are doing out in the field, which this past year, those 4 missions were a science mission, extreme delivery mission, equipment servicing mission, and an autonomous navigation mission.
Okay. So with those missions, you highlighted what those 4 were there are. Tell me a little bit more about the extreme. What is that?
So the extreme delivery mission, we've had different variations on it in the past, but this is the event that takes place in the terrain most immediate to MDRS. If anybody has had a chance to serve on crew out there or is familiar with the terrain out there, we've got a lot more interesting geology that we're able to play with and topography there that we use to our advantage. And so this is our opportunity as judges just to have as much fun as possible and send the rover longer distances, send them over larger drop-offs, up really steep hills. Basically, it's an excuse to do just a bunch of off-road joyriding, but actually putting a mission perspective on it, giving the team something they have to accomplish, whether it's delivering things to astronauts or going and identifying a science sample in the field in acquiring that.
Okay. And speaking of extreme delivery and the various missions, tell me about the mystery rock. What is that?
Yes, the mystery rock. So every year we're looking to put a little bit of a different twist on each of the missions to try to make it fresh and unique and force the teams to solve different problems this year. So this year we really wanted to incorporate a science component with the extreme delivery mission, something that hasn't been a major aspect of that specific mission in the past. So this year, and I'll emphasize that for this mission in particular, it is gated or has stages. So there is a first stage that had this year, I believe there were 60 points available. Teams have to meet a certain minimum score in stage 1 to unlock stage 2, where the additional 40 points were accessible. They had to do that within a specific time frame. And then if they were able to unlock stage 2, it would come with additional time that they were able to use on course. So within stage 1, the majority of the points were scored by identifying this mystery rock. And the clue that we gave to teams was that it was a rock of biological significance. Something that is definitely unique to operating here on Earth and specifically in the desert environment out in Utah. It's hard to say what a rock of biological significance on Mars would be because we haven't found one yet. We don't know what it'll look like. So we require teams to have a good understanding of their environment there. But we didn't tell them anything else. We gave them a center point of where their search was located. And we told them that this rock was located within a 20-meter radius. Now, there was a prior objective teams could do that was only worth 5 points. It took time to do, but if they were bold enough to try to do this, it would actually unlock a clue. So they could narrow down their search to one of the quadrants within that search radius. So they could cut down the search area by 75%. But then basically you're looking for the interesting rock in the middle of a field of other rocks that are somehow interesting. Definitely was extremely difficult. Lots of different interpretations on what the judges meant by biological interest. It ended up being a piece of petrified wood, something that is not uncommon to find in the desert if you know what you're looking for. But there were a lot of teams that were just searching endlessly for that mystery rock, and we had 3 or 4 teams that were able to find it, and it was pretty exciting when those teams were successful.
Wow. So only 3 or 4 of the 37 were able to find that one rock, or the
it was a really hard challenge. The teams certainly learned a lot. We learned a lot as judges. It taught us a few things that we think are areas where we can really help teams refine their systems in the coming years. So I think a lot of people are always a little dejected at first when there's that high of a failure rate, but really URC, it's a learning process, a learning program, and every failure, every setback like that is an opportunity to learn, get smarter, get better, and come back even stronger the next year, both from the competition standpoint, what we're able to teach to the teams, and then the systems that the teams are able to deliver.
Yeah, absolutely. No, that makes a ton of sense. So from your perspective as director, I know you've been with URC for almost 15 years now. In general, how would you say that the competition has changed over that time frame? Obviously, you introduced the mystery rock, but can you tell us, some other examples and other ways that the competition has evolved over the last 15 years?
Oh, immeasurably, especially if you go back to the very first year, 2007 was when we had the first URC finals. We only had a couple of teams entered. When we announced the competition, we barely knew what we were doing. A competition like this had never been held before. I didn't have experience running events that were that large. We put out some announcements. We had a few teams registered. We ended up with about 2.5 working rovers out in the field. And we were just kind of winging it with the task. We come up with a loose set of rules, and we worked our way through it. And it was a great opportunity. I've emphasized learning opportunities in the past. It was just tremendous in that regard for everybody. But the rovers were barely functional. They were able to travel maybe 50 meters across the desert. And then over the years from 2007 forward, and really I'll say that probably the most influential time period was those first 5 years, because around that time, the availability of hardware to support robotics development just completely exploded. I go back to the very early 2000s when I was an undergraduate student trying to build a Mars rover, which was the goal was to test it at MDRS. And I remember taking an entire summer where all I did was research parts to build a rover, and it was excruciatingly difficult, especially when you're trying to do it on a college student's budget.
Right. Yeah.
But the availability of parts, the knowledge that is now available online to do this, that all exploded. And so that first 5 years, there were these huge leaps. And ever since then, it's been the growth of the teams and the number of teams competing that have started to be this kind of cycle that feeds itself, of the students are passing on this knowledge every year. The teams are learning from each other at the URC finals. The videos that are out on YouTube are helping to build that broader knowledge base. And so it's kind of become a self-supporting cycle now.
Yeah. Okay. Well, speaking of learning opportunities and gaining knowledge, in your opinion, how do you feel the URC students benefit from participating in the challenge?
The importance of project-based education. It's hard to emphasize just how important that is. In college, you learn a lot. There's a lot of focus on textbooks. And I think a lot of engineering and science programs have gotten a lot better about bringing in aspects of project-based education, but it can still be difficult to fit into traditional semester or quarter structure. And so having an opportunity where teams can build these programs that are bigger than any class, bigger than any single discipline, it teaches teams a lot about what the real world is like. Real world where you're out solving hard problems, and specifically when you're looking at space exploration. Space exploration needs the best of everybody brought together, and so teams are really getting a good feel for that early on.
Yeah, absolutely. No, I agree with you there. A lot of the undergraduate and potentially graduate programs as well. Like you said, have an emphasis on the textbooks. This gets you that hands-on experience, get to collaborate in a team. So I think we'll shift gears. I'm going to ask some questions of Tal and Riley. We were just kind of talking about learning opportunities. Can you guys tell me about your background and what inspired you to participate in the University Rover Challenge? So yeah, Riley, I see you first. I'm going to pick on you first.
Yeah, absolutely. So for me, sort of like why I decided to join URC is I've been sort of all my life I've known I've wanted to do science or engineering. And then through high school, I did robotics programs all through my high school. And I got to WVU. I'd never heard of URC before. But I found out about this competition through some friends in the robotics club here. And I joined, and I kind of haven't looked back after that. It's been, as Kevin mentioned, this real world hands-on, very intense team experience that I really enjoy.
Excellent. Yeah. What about you, Tal?
Well, I started my robotics, I guess, pathway back in high school when I did the first robotics competition, and I was obsessed with that during high school. But one of my mentors was in uni on the Nova Rover team, and one time he showed me the Nova Rover, and I said, "That's cool. I'm going to try and get into this." And yeah, went to Monash, joined the Nova Rover team, so that was pretty cool.
Rest is history. How do you think that this competition aligns with your career goals, in the future of robotics or space exploration?
Yeah, so I mean, I guess I'm very interested in working in robotics or manufacturing, and being a chassis engineer on the team, it means that I have a lot of experience with designing for manufacturing parts, prototyping, testing, iterating. And that just gives me that hands-on experience that I guess uni classes wouldn't generally give you. So that's very valuable. And it also gives me the opportunity to learn from other students that have been doing this for a lot longer than I have, simply because they, have worked on many different projects and can teach me a lot. It's really great.
Absolutely. Well, I just have to call out here. I see your background. I'm assuming this is the Nova Rover, and it is pink. I wore pink in honor. Can you tell us about the background? Why pink? Tell us the story there.
So our rover used to be grey, and I guess the team thought, we value diversity in STEM, inclusion in our team. We want to promote more diversity within engineering and STEM altogether. So why don't we make it pink? And I guess it's been really good for us because we take it to outreach events, we take it to various showcases, and it catches people's eyes, and it encourages them to come chat with us about it. And hopefully that's convincing more people to join the team, pursue a career in STEM, especially with high school students and primary school students that don't really know that it's much of it like engineering is an option for them. They get to see that people like them are working on a cool rover, and maybe they can join in the future. Yeah,
I love it. Yeah, absolutely. Encouraging students to get into STEM, diversifying 100%. I'm right there with you. Would you say that the pink gave you a competitive edge?
I wouldn't say so, no. But it makes everyone more excited. So maybe in terms of motivation, yeah, it does.
There you go. Overall team morale then. Yeah, that's what I came at. Well, let's see. Well, I know that the University Rover Challenge involves a series of complex tasks, simulating real Mars exploration scenarios. Can you give me an example of how your team prepared for the challenges, both technically and strategically, to ensure your rover's success in navigating the Martian terrain? Riley, I'll pass this one back to you to start.
Yeah, for sure. So for, doing this sort of competition, you can't just prepare for one aspect of it. It's driver operation practice. It's figuring out what to do when things go wrong, developing plan B, C, all the way down, things like that. So there's definitely a lot of different areas to develop. For us, it was a lot of, operator practice, doing lots of checklisting over and over again, seeing how much time it takes to set things up, et cetera, and then troubleshooting in the field, stuff like that. That was a lot of it for us.
Yeah, absolutely. What about you, Tal?
Yeah, so very similar to Riley in the sense that, every weekend we'll do field tests, like leading up to the competition, we'll do field tests, run through every competition task, check the new systems of the rover, see what's working well, see what isn't working well. And, naturally we get a plethora of issues with our systems, and we go back to the workshop during the week and we try to fix that, go to the next field test and test our new systems. And then on top of that, we've got a Australian rover competition in March. That means, we make these systems for our rover. We take it to competition, get it competition tested, see what works and what doesn't work. And then before URC, we work on those problems and try to fix them.
Yeah. Okay. So in addition to navigating the Martian terrain, that obviously has its own set of challenges and obstacles, but I'm sure the communication, working on a team is one of those. I know that communication is critical, both within the team and the competition organizers. Can you discuss some of the methods and tools you employ to maintain effective communication, and especially during those intense development and testing phases?
Yeah.
There you go. There you go, Riley.
So yeah, for us, our main method of communication is via Slack. We've got topical channels for all the different areas of the rover, and then their main general channel as well. That's the main way to stay in touch with members and see what's happening in terms of team timeline and things like that. And then through our team organizational structure, we have some leads for every sub team. So specific areas like developing the robotic manipulator or the drivetrain or the science payload. That helps keep the communication more in line, because you've kind of got this hierarchy and chain of command for stuff like that.
Oh, for sure. What about you, Tal?
So we'll have weekly meetings divided into our sub teams, like the chassis, the arm, side sub team, and everybody will go through what they've done throughout the week, if they need help on anything, if they need advice on the design or software, try to debug something. But other than that, we've also got Slack as well to discuss different ideas. Sometimes somebody will upload a design that they've just worked on, ask for advice, any criticism that they can work on, stuff like that. Yeah.
Always got to be open to feedback and criticism, hopefully constructive. Kevin, what about you? From your perspective as director, what is communication like within your team and making sure that URC has a successful year?
That's such an incredible question, because I think that aspect gets lost a lot. And especially for students coming up, the importance of communication is difficult to understand where that really translates and how critical it is. But within the URC team, and when I say the URC team, I mean the organizing committee. We have an executive team with judges and general staff members, and then we have to ramp up to build a much larger staff that just supports the final competition event that takes place over a shorter period of time. Unlike a lot of the teams that are centrally located on a campus, they're all generally at the same point in their lives. They're typically all, college students. Well, they're all definitely college students at that point, but usually means that they're within a few years of each other in terms of age. And so there's a lot of commonality that makes it easy and convenient for them to be cohesive and form those teams. And certainly necessary, because they're putting in multiple orders of magnitude more work than we are on our side. And not to take away from what all of our judges put into this as well. But being able to communicate across judges that are at different points in careers, have different demands, some of us balancing day jobs with family life and myriad things. We're fitting URC job in, just on a few hours in the evenings and weekends. And so what that comes down to is our communication has to be effective. It has to be concise. We've got to get the job done as quickly and effectively as possible. And so communication is not just what you're writing into an email or posting into a newsletter or how you're conducting meetings, but it's how you're developing all of your workflow processes as well. How you're developing all of those things comes down to communication at the end of the day. And then when it comes time to actually host the finals, where we are recruiting a team of 30 to 40 staff members, many of whom it's their first time going out to MDRS or participating in URC. And so making sure that we're building the right communication tools to build up that knowledge base as quickly as possible so that all of our staff members are ready to go and support the competition.
Absolutely. So across the board, communication is integral. To be efficient, to be concise, that's critical to the team's success. Well, so that's internal. What about external? Can you describe kind of your team's effort to communicate your project to a broader audience and showcase that to the public?
So we take our rover a lot to various outreach events. We'll take it to schools, to engineering fairs just to show Nova Rover, try to talk about what we do about URC. And then on top of that, we've also got little rover kits that are kits with Arduinos, breadboards, motors, switches that we'll take to primary and high schools, and we'll just get them to go through how to build the mini rover with that small electronics kit. So yeah, it gives them a little bit of engineering in high school.
Yeah, gives them a taste. Kind of plant that seed about robotics, engineering, grow that knowledge. What about you, Riley? What's outreach and communicating with the public? What does that look like for your team?
So for us, it's pretty similar to what Tal mentioned. Menash's team does, and I think we're pretty visible on our campus. We're always driving the rover around and going up steps, stuff like that. So I think it's people are just walking by on campus, and you got a lot of people like looking at you when you're doing that kind of thing. And we're trying to get more in the sort of doing community events as well. We're doing like career fairs or like trunk or treat events around Halloween where we can set the rover up and have younger kids come look at it. And then this past year, we had a pretty successful outreach event that was organized by our electronics sub team. They put a lot of work into getting this done, and it was kind of similar to what Tal talked about with getting a little small, simplified robotics kit that you can get people. It's accessible and can get people jazzed about doing this sort of thing. So for us, it was events for incoming freshmen. And there's obviously people coming into college with this interest in robotics and this kind of project work. And that's a good way to kind of find them and lead them to us so they can contribute and get all the benefits that we do.
Yeah, that's incredible. Idea for you. Speaking of trick or treat, is there a way to make the rover arm like pick up a piece of candy and put it maybe in their basket? How can we make this interactive for them as they're trick or treating?
I think for our rover, I think the technical, the manipulator can do it. It's the rover's thing. So it's sort of having the driver operator that is being able to do the practice and be dexterous enough. And our driver from this past year is definitely dexterous enough to handle that. So.
All right. Well, maybe future, we're going to add that in, make this part of the regular rotation there of what the rover can do is helping with trick or treat. I love this idea. Kevin, what about you? From your perspective, what is community outreach look like from perhaps just a knowledge, getting people aware? What about recruiting? Riley mentioned career fairs. Is that something that you guys participate in to try to recruit potential students to participate in the challenge?
Interestingly enough, for us, it's relying on the student teams and encouraging them to do that outreach, because at the end of the day, they're our best ambassadors. You have a group of very excited, enthusiastic college students that show up somewhere with the rover, and that speaks louder than some old engineer coming and lecturing about something could ever do. So yeah, the students, hats off to them, because they are the ambassadors of URC.
Absolutely. No, I love that. Somebody that's in that role can speak to from their perspective about what they liked about it, how this was beneficial. I think that having that firsthand user story is what's going to get a lot of potential new students interested in participating. I'm curious to hear. So we see one picture here. We talked a little bit about the rovers. Can you describe a design or a key feature of your rover for the challenge? What innovative solutions or technologies did you incorporate, and how did that give your rover a competitive edge in completing some of those tasks? Tal, I'll start with you because I can see your rover.
Yeah. So this year, I guess I can talk about what the chassis team did. Yeah. But we worked on a new suspension. So before we had 6 wheels, and now we've gone down to 4. And that's simply because what we wanted to do was have our wheels pivot individually. So we set about trying to do that. Had no experience with making custom gearboxes on the chassis team. So we researched different gearbox designs, looked at what current rovers did, such as Perseverance and Curiosity, with their pivoting wheels. And we settled on a specific gearbox design, tried to design it. The first iteration was not so great, I'll admit that, but I guess that's inevitable with engineering. We worked on that, redesigned it. And we ended up with what you can see here, which is a small, compact worm gearbox that allows us to rotate our wheels without it being back drivable, which is pretty cool.
That's pretty cool. I think we have a video of this. I'm going to pause for a second. Let's get the video of the Nova Rover. Pause for 1 second. and then we'll play that.
Someone needs to mark. I think it would be obvious who wins when one does, but let's make a line. All right. Someone give us a 3, 2, 1. I think it's closer to us. 2, 1, go. That's a mistake, So, Money man's got it. Come on. Oh, wait. Leave it now. No, I'm still pressing this. You got it. Come on. Nice.
Need to stop, I think. I think we need to turn off the line.
Both rovers have kind of just dug themselves into the ground.
You guys got it. Come on.
Yeah, let's do that.
Oh, no, they're going to take right. They're going to take be quick. Dude, I love your guys' wheels so much.
Oh, thank you.
They're so cool.
Chassis's done an amazing job on them.
I think we tied, to be honest.
Sorry, how much?
How much they weigh?
Oh, the wheels themselves are, I think, 700 and like close to 800.
The chassis itself?
The chassis overall is 23.
23.
Okay.
Deluca. Wait, Deluca. Chassis weight 23.
We're up to 25.
And wheels almost 800.
Wheels are about 800 grams each. Yeah, fully assembled about 800 grams each.
Yeah, so that's the post URC, I guess, celebrations within the teams where we do little rover games with each other. It's a lot of fun.
Yeah, I love it. So it looked like Nova there was losing at the beginning, but then came through and was able to pivot. I heard that. Friends reference, loved it. Yeah, it looks really cool. And I think that we have one other video. Let's see that one next. Here we go. We'll give it just a second. We're going to take which one? Here we go.
Yes.
Is that up?
I think it was up already. I think it was up.
Yeah, so that was the equipment servicing task at URC, where you have to drive around a rocket with various control panels and do very dexterous activities with your arm just through camera views. So it's quite challenging for the operators.
Yeah, for sure. It looks like it. Well, I want to give, we saw Nova, and so now I feel like we got to give Riley and Team Mountaineers a moment to shine. I know we've got some photos. Let's take a look at some of those, and Riley, you can tell us maybe what we're looking at, what's happening. Let's get those up here. There we go.
That one's it's not our rover.
Oh, let me get this one. Team Mountaineers. Here we go. There we go.
Yeah. So that's our whole team. That's kind of after the whole thing. Holding the trophy. It was a very, very good feeling after a lot of hard work. So that was pretty cool.
There we go. Here we go. This looks like the right one.
Yeah, so that's our rover. Wanderer is its name, and that's in the configuration for equipment servicing, like what you saw Tal's rover doing there. So you can see a couple things on here. The wheels that we have were an innovation. It was different from what we've done in the past. So those wheels are composite material. They're made of layers of carbon fiber and fiberglass sandwiched within layers of epoxy. We made these great big 3D printed molds. And the reason we did this is because in the past our wheels have been a lot of components. We actually 3D printed them before. It was big chunks of TPU plastic for the main tread, and then a lot of complex metal plates that all sandwiched together. And it was just a lot of parts, really heavy. So this year we wanted to try to simplify it and make them lighter. So the carbon fiber definitely succeeded in helping us do that. And there's some challenges with any sort of newly engineered system, but that was pretty cool to see. And then our arm, which you can see in this photo here, the linkages in the arm are actually hockey sticks, which was kind of a different design than we've used before. But this was nice because it was very light, very strong, etc. And then you can see at the base of the arm, that's our 2 drive motors. So using just these motors, you can control both the shoulder and the elbow of the arm, which is really nice because then you don't have to have your arm lifting a motor at the elbow, which makes it just easier to use, more efficient, stuff like that.
All right. And then I see we got this one here. What was this challenge?
Yeah, so this competition here is we're in the autonomous navigation configuration, and this mission is sort of about having your rover autonomously navigate between GPS waypoints that are provided by the judges. And as the waypoints, you can see this Aruco marker here in the black and white. That's what the rover is looking for at each location. And as the rover progresses through the mission, you get a greater area of uncertainty. So you get an approximation of, within a certain radius of where the marker is, and then your rover has to do some sort of search for it. So we're using computer vision algorithms on our onboard webcams that you can kind of see on top of the rover there to actually spot the Aruco marker. And you can't really see it in this photo, but at the front we have a LiDAR unit that helps with obstacle avoidance for that mission.
There you go. And then, okay, I'm going to go back once more to the team here. Obviously, you're holding the trophy here. What can you pinpoint or say what was the reason you guys won? What led to your success? What was the thing that helped you guys stand out amongst the competition?
Oh gosh, there's so many factors that go into it. We had a really, really strong team this past year. It was just a lot of talent and a lot of people willing to put in the requisite time to really develop a system and deep dive into all the different components for every mission and keep testing and redoing things, and also willing to put in those man hours of doing the practice and checklisting, developing plan B, C, whatever. And definitely there's a little bit of luck involved. You can do all the preparation in the world, and you're still not really fully ready for all of what you're going to see. But yeah, it was a lot of hard work and dedication and a little bit of luck, I'd say.
Yeah, a little bit of luck does help. No, I love that. Well, yeah, congratulations to you guys in winning this year. That's awesome. I do see we have a couple audience questions, so I'm going to sprinkle those in. The first one that I see is, how does URC affect the careers of the competitors? Kevin, maybe you can speak to this one. Oh, here we go. And what should college students expect from an experience of working with the URC team?
Yeah, so for the URC students coming out of it, they're instantly much more knowledgeable. And it sets them up for success, just across their career with their first job, their sixth job, wherever the career takes them. They're going to be ready to take on bigger, bolder projects. And for college students, it means that you're ready to work in a project environment coming out of the gate. More often than not, if you're just hiring an engineer or a scientist straight out of school into a company and it's their first exposure to working in that setting, there's an expectation that it's going to take a few years before they understand how to operate as part of a bigger team, work within project structures. And so for URC teams already being seasoned professionals, it's able to take them to pretty great places. And we don't formally track where URC students end up, but I'm always amazed by the places that our students are ending up, whether they're going on to post graduate education, getting PhDs, ending up with the number of SpaceX employees that have come out of URC, or a number that have gone to a lot of exciting startups in the space sector. They've been able to put those skills to use.
Yeah, absolutely. I'm sure that looks great on a resume. You have, like we already alluded to before, as having that hands-on experience can be very applicable in getting a potential future role with a space company like SpaceX or as you mentioned, any of the various startups. Another question that I see here, Doug asks, in the future, will URC teams develop a dexterous telerobot for swapping spare parts and outdoor metallurgy? There we go.
It's an excellent question. And in terms of a dexterous telerobot, that really is already what teams are doing. So these are obviously telerobots. They're being driven remotely by students that are kind of closed off in an operating station where they can't see what's happening on the rovers. And we do force them all to do dexterous operations. They have to have a manipulator on there. We briefly saw the Monash Nova rover operating on the equipment service panel. Teams have to do a variety of things, from picking up fairly heavy things like 5-kilogram toolbox to flipping individual switches and doing complex operations like opening the latch on a door that has to open sideways, typing on a keyboard, all from the same manipulator. So a lot of that's already there. Metallurgy, we haven't specifically focused on metallurgy. There's not really a convenient way to have a challenge quite like that, based on the location and just the overall logistics. But yeah, definitely love the mission focus and objective focused thought process there.
Yeah. Staying on that same train, Hendrik asks, will URC also incorporate Ingenuity style aerial components for its competitors?
Oh, yeah. So that has been kind of an on again, off again component of URC for a while. And actually, in some of the early years before quadcopters exploded and became the mainstream, we had a couple of teams bring prototype aerial vehicles. So I remember our first one was actually a hexacopter. But we demonstrated some of that success early on, how they could fit into and amplify what the rover can do. Very similar to what we see with Ingenuity. It's amazing having multiple systems working together, how much more you can accomplish. We had a little bit of a lull a number of years ago after that quadcopter market explosion took off, like we talked about, or I mentioned a second ago. The US FAA put restrictions in place that made operating UAVs at our specific MDR's campus a lot more difficult. So we had to put a moratorium on that. We've been slowly trying to introduce aerial vehicles back into the competition. There are a few of us that are very interested to see how we can do that. The biggest challenge that we have is actually the environmental conditions during URC. Operating in the desert in southern Utah, the one thing that we see weather-wise almost every year is in the afternoon, we get very violent windstorms that kicked it up. I think you could actually hear some of that in one of the videos we saw earlier. But the winds pick up, and so it creates unfair competition. A team that operates in the morning might have no wind conditions. A team operating at 3 p.m., just based on how the schedules fall, might have 40-mile-an-hour winds throughout their mission. So we wrestle with how we can really incorporate it fairly. We did have an option for teams to bring a UAV this year. I think we did have one team successfully score points with an aerial vehicle. So it was good to see that as part of the competition again.
Yeah, that's interesting. The point that you bring up about you've got those kind of outside factors like the weather, the wind picks up in the afternoon. And you said that you guys take that into consideration, trying to level the playing field when building a potential schedule to give everybody the equal playing field. Is that the case?
Yeah, we try to. So we allowed teams the option of fielding a UAV this year, and it was a limited number in single digits. So we made sure that we scheduled all those teams on the same day, and we put them all as the earliest time slots in a day. So they weren't all operating at the exact same time, but we tried to make it so that they would have as even of conditions as possible and wrap up before we knew windstorms were going to kick up.
Right. Yeah, that makes a lot of sense. That would be difficult to obviously anticipate and obviously prevent it 100%, but you can only prepare so much. So speaking of, innovation and trying to find and develop specific tools, one of my questions I had was, can you highlight some of the specific innovative feature or design aspect of your rover that you believe set it apart? Tal, you mentioned the arm here that we can see in the image. How did this innovation contribute to the broader field of science for this technology?
It's a tough question.
Yeah, I know. Multi-layer there. Highlight the specific innovative features.
Yeah, so our arm has a number of cycloidal gearboxes, 6 of them, and they each act as a joint for the arm. So that gives us a lot of flexibility in terms of which way the operator wants to move the arm to get to, what they're trying to manipulate. And then on top of that, it's also got a inverse kinematics software package that one of our team members has designed and programmed and implemented. And what that means is, we can pick a direction in terms of a camera view that we want to move in, and it will move all those joints at a specific velocity to move the end effector or the camera view into that direction. And obviously that means that the operator needs to put a lot less thought into what joint is going to go where so that they can go forward, for example, because they just tell the arm to go forward and it does that. And then we've also got we had a lot of iterations with our end effector, our gripper on the end of the arm, what works good for the tasks that we tend to see at URC, what doesn't work as well. Should we change our end effector depending on what we expect to find at a certain task? And yeah, we settled on our current design, and that's worked pretty well for us.
Yeah. And Riley, same question to you. Can you highlight some of the specific innovative features of your design that would help with, obviously, to win the competition?
Absolutely. I talked a little bit about the wheels earlier, which was definitely a big help this year in sort of reducing weight so that we can kind of budget a little more weight for some of our other systems, which was helpful in kind of giving us more freedom in the design process. For our arms in particular, we took kind of an approach of trying to keep it as just as simple as possible. It's sort of like, you've got these 2 joints, and then at the wrist and actual claw part, it's additional motors, but we try to keep it as simple as possible. Break it, you can repair it relatively easily. If you and sort of similar to what Tal mentioned, we also have an inverse kinematics control scheme, and then also like a joint control mode where you can just operate, tell which joint to turn how much, and that's good for operators if they kind of prefer one scheme or the other, or want to apply them in different scenarios.
Mm-hmm. Okay. Well, I heard you say the word budget, and so that made me think of the project of the whole. Obviously, the competition evaluates not only the technical performance of the rover, but also the overall project management, budgeting, time. How did your team manage resources, including time and budget, throughout the project lifecycle?
For us, we have a team specifically dedicated to doing the project management part. So they're in charge of figuring out our timelines, both external, well, not figuring out, but keeping us on track for the external deadlines, and then organizing our internal deadlines to make sure we meet those. Handling all of the purchasing. So if a team decides, okay, we need, or a sub team decides we need X thing, so the science team needs an instrument, or the manipulation team needs a particular motor, that all goes through the management channel, who's keeping tabs on our funding streams and our budget in terms of what's actually allowed for the competition. So that team is definitely kind of spearheading that effort for us.
Okay, so we got a dedicated team that's their role. They're going to manage those things. Tal, what about your team? Did you guys have a similar structure for managing timeline, budget, overall project?
Yeah, so very similar. I guess our CTO, our Chief Technical Officer, will work on a Gantt chart along with all the sub-team heads. and that just details all the milestones that we want to hit before the competition and where we should be at certain points in time. And we try to follow that Gantt chart as best as we can, just so that we're actually finishing our projects on time and have ample time to test our systems. So that's how we manage our time. In terms of budget, we will at the start of the year we'll say, okay, we reckon we'll have this much to spend in our rover. How do we allocate it to each sub team so that everybody can do what every sub team can work on the projects that they want to work on? Obviously, that also means that some sub teams won't have as much money as others in other years. For example, if the arm gets a big upgrade one year, they'll get less funds to work on the next year because they can just try make small improvements for the arm, while a different sub team gets allocated more funds to work on their project.
I'm curious, what does that budget look like? What do you guys start with? You have a pool of monies that's come from the university. You guys are all just pooling your extra funds together. What does that look like? And maybe that's a little intrusive, but I'm curious. Where do you guys get the funds from?
So we obviously get sponsored by our uni in terms of funds, resources, workspace that they give us. And then on top of that, we also have a very awesome and dedicated business team who not only manage the social media of the team and how we present ourselves to the public, but also try secure different sponsorships from companies. So they'll try to find funds. Obviously, that's a big one in terms of building the rover, attending competition, because that is a very big expense. And then on top of that, they also look for in-kind sponsorships from various local companies, such as machining companies, companies that sell products that we tend to use in our rover, and maybe they can give us a discount because we can offer them a sticker on our rover or social media post, that kind of thing. So that's what they tend to work on.
Absolutely. I'm sure for both teams, you guys rely on sponsorships and partnerships. Who doesn't love a discount? Riley, would you agree? You guys have a similar setup for getting funds for the program?
Yes, it's similar. We have support from our MAE department and our computer science and electrical engineering department. We've had a couple of donors who are alumni who've helped out the team. Support from our local like NASA branch in our neck of the woods, which has been nice. And then we're trying to reach out more into private companies for donors and stuff like that. Yeah,
absolutely. That may be a good way to get more funding for the program, is definitely reaching out to those private orgs. I see we've got one more question from the audience, and I'm curious to know the answer. So I'm going to pop this one in here before we wrap things up. Question from Hendrik: are nighttime operations a potential goal for the URC with lunar missions and Mars lava tube missions in mind?
Yeah, so that's a good easy one to answer. So for URC, we're not looking at night operations, and it's driven by just the logistics of where we operate and the safety of getting teams in and out of the desert with it being a remote environment. So we're not looking at for URC. However, that is actually one of the competition missions for the Canadian International Rover Challenge, which actually just wrapped up within, I think, the last day or so up in Drumheller, Canada. So Canadian International Rover Challenge is one of several Rover Challenge events that take place now. This, like several others, was started by URC alumni from the University of Saskatchewan, I believe it was, started that event. They are running the rovers at night.
So there is other rover competitions that are testing that specifically for nighttime. Got it. Yep. All right. I like it. We're just about time. I'm going to ask one final question. So let's end on a high note. What were some of the significant lessons that you learned, and how are you going to carry these forward in your future endeavors?
Well, I guess on my part, and I guess this relates to every single URC student, it's just simply how to work on with a team on a common goal, one project. And that's obviously very valuable as you move into your career, where obviously you're going to have to be working in a team of people in a very similar fashion.
Yeah. You can apply that skill anywhere. What about you, Riley?
Definitely a similar answer. I think the biggest thing for me is the camaraderie you form with this team, and it's sort of learning to love the teamwork and love the craziness of this project timeline when you're working on a system like this. And in order to, because obviously in the modern world, if you're going to develop a complex system, you can't just have one or two people working on it. You've got to have people from every background on all the different types of engineering and outside of engineering as well, with science and on the management side. So learning how to work with all these people effectively and really produce something of quality it's really valuable, because that's what I'm going to be doing in my life. So it's been good.
Yep, you both said it great. Yeah, being able to work on a team, that's an invaluable skill you can apply anywhere. What about you, Kevin? What have you learned from the various years of URC and the challenges, and how do you take this into your other areas of your life and your professional job?
Yeah, so I'm not a student anymore. I'm on the end of making the competition hard and exciting for the students, but at the same time, it is a learning opportunity for me. You mentioned in my bio that I'm in the program management field now, and frankly, a lot of that comes from the experience of URC. URC is running a large, complex project. If you just look at behind the scenes of what is required there, and so as I've matured in my career, started as just an entry-level systems engineer, but URC was kind of my project management sandbox, where I got to get hands-on lessons learned far ahead of any experience that would have been given to me in my career, and that's what's helped me become hopefully a strong program manager now, moving into more senior roles. So I'm learning something every year. Each year at URC, I take something technically away from the teams. This year, we learned a lot just watching the teams look for the mystery rock. It taught us a lot about things that we can pass on to teams about understanding the difference between video and imaging. Teams were looking for a mystery rock with video this year, but imaging is something entirely different. And it's the difference between a shaky video on your phone, which is what a lot of the rover feeds look like, versus a professional photograph that is framed and composed where you can zoom in and look for details. And that's something that hadn't occurred to us to work with teams on. So it's going to be a point of emphasis in the future. And then the last thing is URC. It's almost like an annual refresher course for me on just the enthusiasm and motivation the students bring. By the time we get to URC, from all the planning and preparation, I'm exhausted before day one of URC. And I'm always thinking I'm getting too old for this. And then by the end of URC, I'm refreshed and rejuvenated, and it gives me enough momentum to go for another year.
To do it for another year. Oh, I love that. Well, URC is honestly so lucky to have you leading. And again, every year you come back invigorated, ready for the next competition, and to give this opportunity to these students to continue learning, develop their own skills, the technology. So it's a valuable experience. And so, yeah, thank you to you, Kevin, for doing this every year and selflessly leading and getting these students involved. So with that, we're going to wrap up for today. I want to thank everybody for joining in, everybody that had great questions. I appreciate everybody's participation. Thank you to Kevin, to Riley, to Tal for participating. I learned a lot today. I know I'm going to be keeping tabs on everybody now, seeing what you guys are doing with the rover and where you may end up after graduation, working for a potential company doing robotics. I hope to see you all in those roles in the future. Special thank you to the Mars Society team. Thank you, James Berg. Thank you, Michael Stoltz. Our friends at Liftport, Michael and Leah. Thank you for all your help. And again, thank you everybody for your participation, joining in today. Thank you, you guys, for answering all my tough questions. I know it's not easy to come on here and get grilled a little bit by my questions and conversation. So I thank you, everybody. And remember, as I always say, the best is yet to come. Hope everybody has a wonderful rest of your day and a good week. And we will see you guys next month. Bye, everybody.